Really, the best way to do it is try to remember our perfect squares. You remember the perfect squares of 1, 4, 9, 16, okay, 25. You guys remember how I got that? I got 2. Remember, 2 times 2 gives you 4. 3 times 3 gives you 9. Shh, guys, hush.
Yeah, you said 4 times 4.
4 times 4 gives you 16.
Then 4 times 4, 5 times 5. Yeah.
Remember, to simplify these, we need to figure out which one of these perfect squares can go into 52. Okay? Now, the best way to do it is just try them out. You can already look at it and tell, okay, 25 is not going to go into 52. You can kind of know that. Can 16 go into 52?
No. No, 16 can't go.
Okay, can 9 go into 56? 52.
No.
Can 9 go into 52?
No.
Can 4 go into
Yes.
52? How many times?
13.
Okay. So if you multiply 4 times 13, you get 52. Now, this you split it up by doing this. Okay. This is how you simplify these. Dylan, please stop.
I'm not even doing anything.
Okay.
I think I had to get like the exact numbers straight.
No. If you type in the square root of 52 in the calculator, you're going to get a long decimal. Yeah, it's not going to work out. Okay. So that's why you need to simplify it by determining which perfect square can go into 52 and determine how many times it can go in. So we figured out 4 can go into it 13 times. 4 times 13 gives you 52. Now, what's the square root of 4? 2. And we can't simplify the square root of 13 anymore. So you would just write it, drop it down right there. All right? So this is how you simplify these square roots or these radicals. All right? Just determine which perfect square can go into it. Does everyone understand the concept of perfect squares? Okay, 2 times 2, 3 times 3, you know all that, 4 times 4, okay? So what those are. Make sense? To our square root of 45. Okay? You know that. Well, I'm just going to write my perfect squares over here on the side. Okay? We know that 9 times 5 gives us 45. So, 9 times 5 gives us 45. And 9 is a perfect square. Okay? So the square root of 9 becomes 3. Alright? Can any of our perfect squares go into 24?
Yes.
87.
Can any of those perfect squares?
No, I'm watching. I really am.
Please turn.
Look, I've already got all this. Check it out. I actually took notes.
Okay,
that
look
day.
over it again, please.
Androids and Samsung.
At this thing is multiply 2 times 24. Guys, get a sheet of paper out or something. Quickly. Okay, that'll give you the square root of 48. Can 16 go into 48?
Yes.
How many times? 3 times. Okay. So 16 times 3 gives us 48. Now what's the square root of 16? 4. And we can't simplify the square root of 3 anymore. Okay? Because remember, square root, let's simplify the square root of 32. Okay, we figured out what perfect square can go into it. All right? And we've simplified that. I'm going to erase the one on the right because we've already talked about that. Okay? Now, here's the tricky part. Guys. Now, remember, anytime you have exponents and variables like m to the second, okay? If we're finding the square root of that, remember, square root is just the same thing as something times something gives me m squared. What? So if I had x times a, well, let's use m. Oh, let's change this up right here. something times something gives me m squared. What are those blanks? What times what's going to give me m squared? Remember, it has to be the exact same number because we're talking about perfect
I
squares.
know it's gonna be M and M.
M and M. Perfect.
M shall eat the best thing.
Okay? Because, guys, remember our exponent rules. Anytime we multiply exponents, we add them. Okay? So I have m to the first times m to the first. That gives me m to the m squared. Okay? That's the exact same concept for square roots and radicals right there. All right? So, that simplified, m squared simplified, is just going to leave me with m. Same thing for n. How do we simplify the square root of n squared? Yes, n times n gives me n squared. So that simplified is just going to be flat out n. All right? Now the last one we have to talk about is c. In terms of that, in terms of the square, I'm running out of room. In terms of the square root of c, okay, is there anything times something times something? Is that going to give me c?
Yeah, C to the half.
Well, no, remember you can't have fractional exponents like that. Well, if you did c times c1 times c1, you get c squared. So there's some cases like this, you cannot simplify that. That has to stay underneath that radical sign, all right? So, now lastly, let's put everything together, all right? Let's put our 4 out front. Remember, our m and n got out of that radical, okay? We simplified them out of that radical, all right? Now, inside the radical, or the square root sign right there, we have a 2. What else do we have? A c.
Yeah, dude, what is now?
Exact same thing. I'm going to break this up into, I'm just going to break up my bases, okay? So I'm going to break this up to the square root of 45. Okay, the square root of a to the 4th. Square root of b to the 5th. All I'm doing is breaking these things up, all right?
Yeah, but
And the square root of c to the 6th, all right?
how would you do the odd number?
We'll get to it. Now, square root of 45. How do we do that?
9 and 5.
9 and 5, because 9 is a perfect square. Okay? So, the square root of 9 times the square root of 5 will give me 45. So then simplify that even more, you get 3 times the square root of 5. Does that make sense?
Alright.
Now, what is a to the a squared? Good, because a squared times a squared gives me a to the 4th. Does that make sense?
Yeah.
So then, that's simplified, just going to be a squared.
Go to the B to the 5 now.
All right. Now, anytime you have an odd exponent, you have to break it up in a way that you can simplify it. What I mean by that is, let me erase this square root of c to the 6th. So we need some room. Okay. What I mean by that, you need to break it up so that you can simplify it by, if we simplified b to the 4th, what's that going to be?
B squared.
B squared. Okay, good. But we still have that b left over here. Because remember, b to the 4th times b gives me
Then how can
b
you
to the
just,
5th.
why, since it's a 5, why don't you just round up to a 6?
Can't round up. You got to round down. If you want to think about it like that. Or you can think about it as, if whatever number, say if it was like a b to the 21st, you would round it down to 20 and 1. You pretty much, you round it down, you make it an even number, essentially, is what
Yeah,
you're
no,
doing.
but like, wouldn't you round it up because it's like an even number up?
No, not round it up. Got to round down.
Now what
Yeah.
happens if you round it up though?
So
Get it
it's
incorrect.
B to the 4th,
Huh?
that's the 5, or is it
What?
B to the 2nd?
Now, can we simplify this?
Yeah.
Now we can.
B to the 2nd.
So we got b to the 2nd, and can we simplify this?
No.
No.
No, it stays underneath there.
So
Okay.
it's just a special B.
It just stays there. Good, you guys got it now, I think. You guys are doing good.
Okay, C to the 6.
Okay, what about that? C to the 6 simplified.
3 times 3.
C to the 3rd.
Yeah.
Okay, because if you multiply that out, you get C to the 6. Now, lastly, I'm going to combine all my simplified terms together. All I'm going to do is just match them up.
Oh, wait.
Okay? So, I got a 3. All right? I got an a squared, that's on the outside. I got a b squared, that's on the outside. And then I have a c to the 3rd, that's on the outside. What's left inside?
The 5 and the B.
The 5 and the b.
Yeah. Got it. I understand now, Suave.
Okay?
Oh.